Hello friend, today we shall talk about the topic OPC-DA protocol. OPC-DA protocol is a very popular protocol in cybersecurity. OPC-DA stands for Open Platform Communication Data Access, which is an older protocol used in industrial automation to facilitate communication between different devices and software applications. Unlike OPC-UA, which is the most recent and applicable protocol, OPC-DA is more limited in its security features, but understanding its basic principles and how it handles cybersecurity can still be helpful. So let's talk about in detail what is OPC-DA actually. OPC-DA allows devices and software applications in industrial settings to exchange real-time data such as sensor readings or control signals. It's like a common language that different systems use to share information. Cybersecurity in OPC-DA, if we talk about, while OPC-DA lacks many advanced security features of OPC-UA, some basic measures can still be applied to enhance its cybersecurity. These measures focus on restricting access, monitoring activities, and protecting data. Now we can talk about the key cybersecurity measures for OPC-DA. First one is the access control, ensuring that only authorized users and devices can access the system. Network security means protecting the network through which data is transmitted. Data integrity means ensuring that data is accurate and hasn't been tampered. Monitoring and auditing means keeping track of who did what and when. Now, how these measures actually work. First, we talk about access control. Imagine a factory with machines that can be controlled via software. So you don't want unauthorized people to change the machine settings. So how it works actually, we use the user authentication, means users must log in with a username and password. Only recognized devices are allowed to connect to the system. Unauthorized devices will not be connected to the system. Then network security. Suppose your factory uses a local network to connect devices. You need to protect this network from external attacks. So how it works actually, we use firewalls. These act as barriers that monitor and control incoming and outgoing network traffic based on security rules. We also use VPNs, virtual private networks. These can create secure connections over the internet, ensuring that data can be transmitted safely. Then data integrity. For example, your factory sensors send data to a central database. You need to ensure this data is not altered during the transmission. So how it works actually, we use the checksum. That means when data is sent, a small piece of data called checksum is generated. The receiving system uses this checksum to verify that the data hasn't been changed. Then monitoring and auditing means if there is an unexpected change in machine settings, you need to know who made the change and when. So how it works actually, the system keeps detailed records of all activities, including who accessed the system and what actions they perform. So if we put all together all these things, so imagine your factory as a network of machines and sensors connected to control software. OPC-DA helps them share information. So to keep everything secure, you implement these measures. Access control, that means only authorized users and devices can access and control the system. Network security means the network is protected with firewalls and VPNs to prevent unauthorized access. Data integrity means checksums ensure the data sent between devices and software is accurate and hasn't been tampered. Monitoring and auditing means logs, keeps track of all activities, providing a record of who did what and when. So these are the major concepts of OPC-DA control, means access control, network security, data integrity, and monitoring and auditing. Let's talk about a practical example. Let's say you have a temperature sensor that sends data to a control system every minute. So access control means only authorized personnel can log in to view or change the sensor setting. The sensor is recognized by the control system, so no unauthorized devices can send data. Network security means the data travels over a secure network protected by a firewall and a VPN, preventing unauthorized access. Data integrity means each data packet from the sensor includes a checksum. When the control system receives the packet, it checks the checksum to ensure the data is accurate. Monitoring and auditing, the control system logs every data packet received along with the time and source, so any issues can be traced back to their origin. So while OPC-DA does not have as many built-in security features as OPC-UA, implementing these basic cybersecurity measures helps protect your industrial systems from unauthorized access, data tampering, and other security threats.